I'd like to spend a couple minutes here on problem number 10 from your review sheet, which is a good word problem and covers many of the concepts that we have been covering. So it says from 2000 to 2005, the average price P and the average cost C for each toy a company produces can be modeled by a couple of functions. P of X is equal to 5 plus 0.5 X, and C of X is equal to 0.1 X squared minus 0.5 X plus 2.4. Now looking at this, P, which is price, is a linear function. So I can see that my price every single year is represented, X is equal to year. Every single year is going up because I started at 5 and it increases, looks like 50 cents a year. My cost is a quadratic. So that's going to be a parabola. I'm not sure exactly how that's going to look year by year until I actually work it out. That's my cost. So one of the things that they're asking me, I'm going to skip the last part of the data just for a second here. In section A is the total profit. And the total profit, so profit is equal to what you get, your price, minus your cost. So for each toy, because these two functions are per toy, that's the average price per toy, and that's the average cost per toy. So for each toy, the profit is going to be P of X minus C of X. Well, that's a pretty simple equation, pretty simple thing to do. I'm just going to take those two functions and subtract one from the other. So my P of X is 5 plus 0.5x. That's my P. And I'm going to subtract from that my cost, which is 0.1x squared minus 0.5x plus 2.4. So now I have a situation where really all I have to do is subtract two polynomials. Well, I'm going to start off with my 5 plus 0.5x. But I have to remember, since I have a negative sign here, I have to distribute that negative sign to each of the terms inside this function. So that's going to be minus 0.1x squared plus 0.5x minus 2.4. Let's take a second here and combine our like terms. So I'll start with my highest power right there. So my first, and that's the only one that's an x squared. So I have negative 0.1 x squared. Get rid of that one. Now I have a couple terms with x in it, 0.5x and 0.5x again. That's going to be plus 1x, half an x, plus half an x is a full x. And then my constant-like terms are a 5 and a negative 2.4. That's going to be a positive 2.6. That then is the answer to part A, which is asking for the profit over time per toy. Now, the other piece of data that they gave us in the beginning of this question was they said, well, how many toys are produced each year? Because to know how much you make on one toy isn't really that helpful for a company. You need to know how much you make total. So we have to say, how many toys did we sell? And there's a function for that too. So the function is Q of X, and they say that is 5,000 plus 2,000 x. So again, another linear function. it's saying that in year 0, which was the year 2000, we started with 5,000 toys, and each year we manufacture 2,000 more. But what we need to have, what they're asking us for in the second part, is according to the model found in part A, which is this, what happens to the total profit over time? So total profit will be equal to profit per toy times, well, the number of toys. If I make 5 toys, I get 5 times the profit, whether it's positive or negative. So I have a function for the number of toys, and I have a function of the profit per toy. So now I'm going to multiply those two functions. Excuse me. I'm going to have my 5,000 plus 2,000x, which is the total number of toys. And I'm going to multiply it by my profit per toy of negative 0.1x squared plus x plus 2.6. Okay, so let's do it. I have 5,000 times my negative 0.1x squared. So I'm going to be starting off with negative 500 x squared plus 5,000 times my x. So that's 5,000 x. And then 5,000 times 2.6. That is 13,000 plus 13,000. And then I have my 2,000. So I'm going to go 2,000 times my 3 different terms. So 2,000 times negative 0.1x squared is minus 200x cubed. Pay attention to that x there. Got to pay attention to the powers. And then I have 2,000 times x. So I'm going to have plus 2,000x squared. And then I'm going to have 2,000x plus times 2.6. And that's going to give me a plus 5,200x. Let's combine like terms. I'll start with my highest power, which is right there. So I have negative 200x cubed. That's the only cubed power that I have. And then when I look at my squared powers, I have negative 500x squared, and I have a positive 2,000x squared. That's going to give me a plus 1,500x squared. Now I can look at my x terms. I have 5,000x, and I have 5,200x. So that's going to give me a plus 10,200x. And then I have my last one as a constant, plus 13,000. That's the formula for total profit per year. X is equal to years since 2000. Now the question asks, according to the model, what happens to the total profit over time? Well, this is our total profit over time, and what's going to happen to it? Well, if I'm making it into a graph, my highest power is 3, which is odd. And my leading coefficient of my highest power, of my term with the highest power, is negative. Okay, well, I'm thinking here, what does that mean? Well, I know that x cubed, that's what I always go back to, my x cubed, which is positive but odd, looks like this. If I then change my leading coefficient to negative, then my x cubed graph is going to look like this. Well, this graph is of a odd highest power. The leading coefficient is negative. That means I'm going to have an up, down, end behavior, which means that over time, and time is our x-axis, our time is going this way, it means that over time, our profit is going to go down. Well, that doesn't make me really happy, but that's something that we really need to know, that over time, oh, guess what it's telling me, is that our costs start to increase faster than our price is able to increase, and our profit will go down. So I'm looking for a little bit of proof of that. And I entered my formula here into my TI calculator, and I graphed it. And sure enough, that's what my profit looks like. In year 2000, it starts and it's going up and up, but then I guess that my prices start to increase, my costs start to increase faster than my prices, and my profit starts to go down. Just so you know, I had to do a lot of fiddling with the windows on that. I mean, I knew that I couldn't have negative years from 2000, so I could start my x min at 0, and I took my x max out 10 years, even though they were only asking for 5. And then my y minimum, I just made a negative 13,000 because this was a positive 13,000. And for my y maximum, I actually started out at positive 13,000, but my graph kept on going above the window there, because I do have the first couple of years my profit is going up, so I just kind of went higher and higher numbers until I found like 30,000, and that gave me a picture of the whole thing. But sure enough, my end behavior of this this function is down, and I'm going to have profit going down over time.